Good afternoon and welcome to Turner & Townsend's presentation on procurement, package management and cost engineering for the offshore wind industry. My name is John Fowlie and I'm Turner & Townsend's Regional Director for our natural resources business across Asia, which includes the renewable sector, where a key focus area is supporting the burgeoning offshore wind industry across North Asia. I will be providing a brief overview of Turner & Townsend globally and our relevant experience and capability before handing over to our senior consultant, Garry, who will take us through a number of key themes relating to offshore wind package management and procurement. Turner & Townsend is an independent professional services company. We specialize in program management, project management, cost and commercial management, and advisory services across the natural resources, real estate, and infrastructure sectors. We are recognized globally for our expertise in setting up and delivering large and complex capital projects, the foundation of which is our experience, lessons learned, and data gained from 75 years of operation across 8 global regions. We have no ties to any design, construction, or engineering team, so we approach every management task with an independent mindset. We found that this independence is highly valued by our clients, whether they've commissioned us to assess a program's progress, handle their commercial interests, produce contractor agreements, or get a project back on track. They can be sure that the information and recommendations we provide represent a balanced, objective view. Turner & Townsend are committed to open and transparent communication with clients, project teams, and in our project reporting and analysis. We take a collaborative approach to information, establishing mutual understanding of project objectives and strategies, as well as roles and responsibilities. That's how we provide clarity so everyone can see the path ahead. So a few of the highlights of Turner & Townsend's business globally now. We've grown rapidly over the last 10 years and we currently stand at just under 7,000 staff globally, operating out of 111 offices across 45 different countries. Turnover last year was an all-time high at just shy of £750 million, and to date we've completed just under 12,000 projects across the world. This slide shows the truly global nature of Turner & Townsend's operations. Pinpoints the 111 offices that we currently have, and obviously today we're focusing on the Asia region and in particular Korea, and we have our office in Seoul that's marked there, but we also have offices across the other major offshore wind centres in North Asia, including China, Taiwan, Japan, and also Vietnam. And now moving on to Asia. Turner & Townsend currently have over 700 consultants spread across the Asia region, and several years ago we established a joint venture in Korea with Hamni Global, a leading Korean company in construction management. The joint venture provides systematic and professional cost management services across the Korean construction market in all the sectors that we operate in. Now moving on to the services that Turner & Townsend offer. We transform how projects are run. We safeguard the interests of our clients and we deliver better outcomes for them. Every sector and market has its own trends and challenges, but no matter what we're working on or where a project is, our approach remains the same: to make sure complexity is managed and our clients' goals are met. We're focused on better outcomes, and with so many moving and independent parts, large-scale projects and programs can take on a life of their own. But we know with the right kind of management, any project can be kept under control. We relentlessly apply our tried and tested systems and processes for the analysis, planning and monitoring of projects to deliver faster, cheaper, safer and more efficient working practices and better results overall. The boxes you can see on the slide there just summarise some of those services that we offer, and it really goes across the full gamut in the commercial space, from advisory services through to project and program management, cost and commercial management, including cost estimating, benchmarking, cost assurance services, through to procurement and supply chain strategies, which Garry will talk about a little bit later, controls and performance, HSE, and technology and data. In the energy space, we support our clients' project delivery across the full gamut of conventional, alternative, and renewable power. We have extensive experience and capability across all segments, including the final transmission and distribution networks. We work with the world's largest and most respected players in the energy market and have long-term global agreements in place with many of them. Our clients include the international oil and energy companies, key national oil and energy companies, major national and international utilities, finance houses and developers, and the major EPCs and engineering houses. Turner & Townsend have been supporting our clients in Asia for over 30 years and have worked on many of the largest and most complex capital projects across the sectors in which we operate. Everything from multi-billion-dollar offshore and onshore hydrocarbon projects through to the development of one of the world's largest copper deposits and mega expansions at some of the world's largest airports. This slide just shows a sample of some of the projects we've been involved in, but if you want further details, please do not hesitate to ask. This slide provides a selection of some of the offshore wind projects Turner & Townsend have worked on. We have delivered services to offshore and onshore wind development projects in Africa, the Middle East, Germany, the UK, and South Korea. Our JV partner in Korea, Hanli Global, has significant experience in both onshore and offshore wind projects. This slide just shows a few examples of the work they've completed in recent years. And now I'll hand you over to my colleague, Garry Knight, who will take you through the remainder of the presentation.
Thanks, John, and hello everyone. Thank you for joining our webinar. My name is Garry Knight, and I will be discussing a number of key themes relating to offshore wind package management and procurement. This will include best practice contract strategy, development, and how to maximise value from the supply chain whilst mitigating contractual risk. So, as an introduction to this topic, you will all no doubt be aware of the steadily improving competitiveness of offshore wind. Following 2 decades of development, construction and operation, offshore wind has proved it has a significant role in the transition to net zero. With climate change concerns at the top of national agendas around the world, ambitious targets for this energy source are being set, driving technological and geographic change. As the industry matures, the ways of procuring and managing the wide range of high-value contracts required in delivering offshore wind farms has evolved. Choices depend on the capability and financial strength of the project developer and the supply chain, as well as the method of financing the project. Key to setting up these major infrastructure projects for success is a solid understanding of these issues. This is critical not only for governments who are looking to these major projects to deliver the much needed demand on the supply chain to create jobs and strengthen economies, but also essential to industry advancement and ultimately the drive towards net zero. This presentation will focus on package management and procurement, which is a specialised skill required throughout the development and construction phase of offshore wind projects. In managing procurement and key project delivery interfaces, package managers need to streamline communication, identify risk, monitor progress across the multidisciplinary project teams, and ensure a focus on health, safety, the environment and quality. So what is essential in establishing a robust procurement strategy? Well, there are a number of ways offshore wind developers can procure the wide range of high-value contracts required in delivering an offshore wind farm. No procurement path is the best in all circumstances and has to be adaptable. The way to determine which procurement route to use is to consider the client's priorities for the project and align them against the characteristics of each procurement option. These choices will depend on the capability of the supply chain and the financial strength of the project developer, as well as the method of financing the project. There are a number of procurement options commonly used in offshore wind, including EPCI and turnkey options, multi-contracting approaches, together with transport and installation and partnership and alliancing strategies. The strategy for the selection of the most suitable form of procurement is fundamental to the achievement of the client's objectives, namely completion within the client's budget, to the required standard and quality, and within the project timescales. It is also important to fully appreciate the client's attitude to risk and the expected return on investment. A procurement strategy workshop can often be the best way to review the procurement options, discuss the key risks associated with each option, and review the major influences on procurement selection. So far, we have established that package management is a specialised skill set, both during the development and construction phases of an offshore wind farm. A typical offshore wind farm will consist of a number of packages which need to be procured and managed prior to construction, and usually before the financial investment decision, or FID, is taken. Firstly, the wind turbine package will normally consist of the supply of the wind turbine itself, which encompasses all of its internal components, such as pitch system, drivetrain mechanisms, and of course the tower and turbine blades. The wind turbine is often supplied by the manufacturer with an option for installation, and in most cases the wind turbine contract or technical supply agreement is negotiated along with the service or maintenance contract. Secondly, the foundations package, which consists of the development of the design and fabrication of the selected foundation type for the wind turbines themselves, and potentially those for the offshore substation platforms. The final selection is dependent on water depth and seabed conditions, but the most common foundation types are monopile, piled jacket, suction caisson jacket, and gravity-based structures. We will see the introduction of non-fixed or floating foundations as this technology matures over the coming years. The transport and installation package generally focuses on the transport and installation options for the foundations once fabricated, and includes all of the relevant engineering and vessel-related activities associated with the transport and installation from the fabricator's facilities to the chosen marshalling port, and from the marshalling port to the wind farm itself. This package often includes identifying and selecting the most appropriate port, both for the foundations and the wind turbines themselves, which will consist of the nacelle, the tower, and the blades. Electrical systems. Well, this package commonly includes the offshore and onshore substation for the transmission of power from the wind turbines, with the supply and installation of infield or array cables, together with the supply and installation of the export cables, which carry the electricity to the inland substation. And finally, the operations and maintenance package. The O&M package would commonly involve determining the strategic options for the wind farm once it's constructed, and often includes determining the most appropriate location for an O&M base. Logistics solutions will also be considered, including that of utilising service operational vessels or SOVs, and transfer of staff to the wind farm using crew transfer vessels or helicopter transfer. It is critical for the success of the wind farm planning that these packages interface with each other and agree what is included in each other's scope of works and manage the risks accordingly. This is both during the pre-construction phase and then throughout construction. So leading from the previous slide, what are the components of successful package management for a client or developer? Well, in my experience of working with developers, there are a number of key success factors. Firstly, the package manager has to be in control from the outset in order to focus on the commercial outcomes, and they will need to ensure that best practice project, cost management and procurement is in place for the package. The package manager will need to communicate successfully, both within his own team, but also with other internal and external package interfaces. The package manager will have an important role to play in the development of the supply chain engagement strategy. They will need to work closely with the procurement and contracts teams to develop tender strategies and to negotiate all relevant contracts within the package with a focus on cost, risk, programme and quality. It is critical that the package manager establishes strong relationships across their package, both internally with design and engineering and cost and finance teams, but other key interfaces such as consents and permits teams, together with, of course, their procurement and commercial interfaces. The package manager should be focused on the structured management of risk whilst maintaining a commercial pressure and tension within the supply chain. The package manager needs to have strong technical and commercial understandings of the package and where the key risks are for project delivery, whether that is in terms of the supply chain or any key programme or technical issues which need to be understood and resolved, often liaising with the engineering teams. The package manager needs to be able to develop a relationship with senior management internally, but also externally with the supply chain, in order to comprehensively present the project and clearly define its requirements. Often, there is not a simple answer to solving complex technical and commercial issues, and the package manager will be required to explore all possible alternatives to reach the required solution by being aware of the whole value chain, including that of key Tier 1, Tier 2 subcontractors, who have a critical role to play in the delivery of the project. So in summary, package managers are required to maintain control through clear communication and collaboration with contractors, and take responsibility for ensuring that their package is running to time and budget against an agreed scope of work. Our clients look to us to secure the best outcome from the procurement process with a balanced approach to risk and commercial issues across these multiple work packages. So there are a number of options open to a client when it comes to contracting strategy options. I'm now going to talk about a couple of the most common contracting strategies for a new offshore wind farm development, namely an EPCI or turnkey approach, and secondly that of multi-contracting packages. Other options which can be considered is a transport and installation strategy, which places a focus specifically on transportation, logistics and installation, or a partnership and alliancing approach where the developer will at an early stage engage with those contractors who are prepared to discuss entering into a joint pain or gain share mechanism for those large offshore wind farm projects. So the first contracting option to discuss is the EPCI approach. So what is it? So EPCI stands for Engineering, Procurement, Construction and Installation, where a few large contracts are placed, each for an end-to-end scope of supply. An EPCI approach would usually involve appointing a single contractor for managing the supply chain requirements. The EPCI agreement, or sometimes known as a balance of plant agreement, will typically include the foundation supply and installation, in-field array cable supply and installation, and the requirements for marshalling ports or harbours, which are often used to store and prepare components prior to transportation to the offshore site. The EPCI agreement usually stands alone from the turbine supply agreement, TSA, which is negotiated separately and will usually include the details of the wind turbine supply, installation and commissioning during the construction phases of the project. The grid operator in some offshore projects will often include the substation electrical supply and the supply of installation of the substation topside and foundation, together with the export cable supply and installation. An EPCI strategy would involve negotiating a significant high-value contract, meaning only experienced EPCI contractors who can demonstrate a strong balance sheet will have the capability to lead and manage such projects. They will often be pan-European or global businesses who have the scale to manage key subcontracts in, for example, the supply and installation of foundations and cable systems, which are often sourced globally. So who uses it? Well, independent developers and less experienced utilities prefer this approach especially when seeking to minimise their own risk in order to secure project finance. EPCI has historically been less common than multi-contracting in the UK market, however in recent years is starting to become more popular with developers due to the scale of new offshore projects. So what are the advantages? Well, it is a highly bankable procurement method. Transferring most of the construction risk to the EPC contractor means that in a properly drafted contract, the contractor should have limited scope to bring claims for extension of time and additional costs. This certainty is desirable by lenders, as this means that the scope of works should be completed on time and within budget. The EPC contractor bears the interface risk of integrating performance of the package contractors, often including the design contractor. The EPC contractor is contractually responsible for all design, procurement, engineering, construction, testing and commissioning of the work. And this means that the EPC contractor, once appointed, will be liable for any defects or problems with the works, removing the opportunity for the contractor to apportion blame to a third party. So some of the disadvantages with this approach. The EPC contractor will look to add a substantial risk premium to the contract price, which may make solutions uncompetitive to the construction phase of procurement, as the construction risks which the contractor accepts will be priced within the contract and contingencies are built into the contract price as a result. As previously mentioned, there are few contractors in the offshore wind market who have the appetite, capability and balance sheet capacity to accept the risk of large projects on an EPCI basis, and it is now becoming more common to see organisations partner on a joint venture basis. However, EPCI contracting remains a popular method of contracting for new offshore wind farm projects and is likely to continue into the future. The multi-contracting approach. So what is it? The multi-contracting strategy involves the client contracting with multiple suppliers who are then responsible for key package and programme delivery. But the multi-contracting approach does allow flexibility in the process for the client or developer to either increase or decrease package scope as required. Typically, there are about 9 main contracts which are awarded covering the key elements of the wind farm. Supply and installation packages are often awarded to different companies, which increases competition for each of the contract elements under a multi-contracting approach. Some packages can be split or combined dependent on a client's needs and supply chain capability. For example, in adopting a multi-contracting strategy, different companies may be responsible for the foundation supply and installation, as opposed to an EPC, where a single contractor would bear responsibility to the client. So who uses this type of approach? Well, multi-contracting has been used by the most experienced developers and clients, particularly if the project is balance sheet funded. These clients take time to invest in the technical and management skills internally and prefer to take on the associated risk rather than transferring this to an EPC contractor and paying a premium. What are the advantages of this approach? Well, the main advantage over an EPC is that it can offer the opportunity to gain the lowest outturn cost to the project by creating a greater commercial tension in the supply chain for winning work. It also gives the client a greater understanding and control of their assets in respect of design and quality, with the opportunity to best optimise, allowing risk to be apportioned between the client and contractor on a case-by-case basis. So the disadvantages of multi-contracting. The multi-contracting approach would often require larger in-house technical and management teams in order to manage all of the tendered packages. All interface management and risk is borne by the client, with no single contractor appointed for the overall project. It requires the client to have experienced package managers who have strong project management, engineering and commercial skills. Finally, a multi-contracting strategy tends to present itself as a higher financial risk option to banks or lenders than EPC, which could affect the number of potential lenders involved and the terms and conditions they may lay under. So finally, what does successful offshore wind procurement look like? Well, firstly, it is critical to know and understand the drivers for each key package which is to be procured. What are the supply chain's capabilities, strengths and challenges? Are there suitable installation vessels available for your project in the timescales required, which can transport and install large jacket foundations or larger turbines, for example? It's vitally important to engage with the supply chain both before, during and after any procurement exercise which is being conducted. Early engagement is key. It is often worth investing time meeting and engaging with the supply chain in advance to discuss the project timeline and the key requirements, together with what services and capabilities they are able to offer. I would also recommend keeping a sharp focus on the macro environment, with COVID-19 as a good example of how supply chains may be disrupted and any trends which may affect key commodities such as steel, copper and oil. Fuel and weather-related risk and costs can add millions of pounds to the capex of a project and need to be understood and managed carefully. Therefore, focusing on the total cost of ownership is critical to the success of a well-procured offshore wind farm. I will now hand back to John, who will discuss cost engineering and conclude our presentation today. Thank you.
Thank you, Gary. Our final slide provides an overview of cost planning and engineering and what is required for project success. Cost engineering is the engineering practice devoted to the management of project cost and involves activities including estimating, cost control and cost forecasting. This is especially important for offshore wind developments and is critical in supporting package management, as the cost engineer will seek to predict the progress of a project and to spot deviations from the program schedule early on. Cost engineering provides early awareness of costs associated with engineering decisions and risks and enables project cost control. Cost engineering supports the refinement of the estimates as the technical baseline gets more consolidated and provides an informed assessment of reasonable and acceptable price for the development. The capital cost of a major scheme offshore can be difficult to control. In the design of most construction projects, by the time 20% of the design is complete, 80% of the costs are committed. Therefore, the ability to control costs at the early stages of the design is essential. Cost planning is a budget distribution technique that is implemented during the design stages of the wind farm's development to break down the cost into cost targets for each element. The cost plan results in a statement of how the project team proposes to distribute the available budget amongst the key packages identified. The project cost plan is a focus for decision making by the client, design team and key stakeholders at every iteration until completion of tender activity. Presenting an aligned procurement focused cost plan to advise and inform the client significantly improves client commercial outcomes and control of the basic design processes. Cost planning techniques can provide an order of magnitude figure for a new offshore wind farm development based on previous similar schemes at the concept stage. The development of a detailed cost plan enables the total cost of a scheme to be controlled as the design develops. As additional information becomes available, the cost plan can be progressively refined to produce more detailed cost targets by incorporating detailed design and engineering information. Successful cost planning enables the cost of a new wind project to be controlled in order to stay within budget. By continually managing the development of design against the cost plan baseline, we are able to provide assurance that the emergent design is achievable within the affordability envelope. It's important that this data is aggregated to enable project clients to benchmark their investment. it is likely that they will need to demonstrate best value to a third-party funder, regulator, government department, or wider shareholder in the programme. That concludes Turner & Townsend's presentation. Thank you very much to Garry for his input, and thank you very much to everybody listening. If you do want to know more about Turner & Townsend and the services we offer, please do not hesitate to contact either myself or Garry. Thank you.